Hello viewers, welcome to my channel and thank you for watching videos. In this video, question number 5a, Calculus 1994, and here we have to show by means of the beta function that this integral is equal to pi upon sine pi alpha. So as I recall, question 5c of 1992, right hand side was same, and there it had been solved with the help of calculus, and I also told that we can solve it with the help of complex variable also. Here we will reach to that point and rest we have already done. So let's do it. Here we put x minus t is equal to u in the left hand side integral. So this gives us x is equal to t plus u, and now we see the limits first. T plus u, when x is equal to t, u becomes 0, and when x is equal to z, u becomes z minus t. So these are the limits, and dx is equal to du. So dx is du. Now we substitute in denominator. This is z minus x, x is t plus u, so with minus sign, this to the power 1 minus alpha, u to the power, because x minus t is u to the power alpha. Now we take another substitution, u is equal to z minus tv. So v becomes u upon z minus t, and limits will be when u is 0, v is 0, and when u is z minus t, v is equal to 1. So limits are 0 to 1. du is equal to z minus t dv. So this is here. Now we take v is equal to u upon z minus t. So what we do, we take in the first term in denominator z minus t, we take common. So 1 minus u upon z minus t. So that becomes 1 minus v to the power 1 minus alpha. And because we have taken z minus t common, so z minus t to the power 1 minus alpha. And this is u. u is z minus t to the power alpha, v to the power alpha. So just cancel out whatever. So z minus t to the power alpha will cancel out with this one, and z minus t will cancel out with this one. So this becomes 0 to 1 integral dv upon 1 minus v to the power 1 minus alpha v alpha, and which we take in numerator is this. Now we compare it with beta function. Beta mn is equal to integral 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx for m is greater than 0, n is greater than 0. It means m minus 1 is minus alpha. It means m is equal to minus alpha plus 1, and n minus 1 is equal to minus 1 plus alpha. So n is equal to alpha. So we write it in terms of beta mn, and just rearrange, interchange mn. So this is an alpha 1 minus alpha. Now we know the relationship between beta and gamma function. Beta mn is equal to gamma m plus gamma n upon gamma m plus n. So this is written gamma alpha gamma 1 minus alpha upon addition of these two, which comes this much, because it is gamma 1 is 1, this cancels out alpha, which is equal to this much. And now we will see how to get this expression. So we know that beta m, n in place of n we have written 1 minus m, will be beta m gamma 1 minus n, and in denominator it will be gamma 1. So it can be written as 0 to 1. Now this is with the help of beta function, x to the power m minus 1 and 1 minus x to the power 1 minus m minus 1 dx. This is the definition of beta function. We put x is equal to sine square theta. So dx is 2 sine theta cos theta d theta. In place of when we put this, we get theta value 0 when x is 0, and theta is pi by 2 when x is 1. So limits have changed, and rest we have put values of x, that is sine square theta, and we are putting power m minus 1. So this becomes sine 2m minus 2, and this is cos, because 1 minus x to the power minus m. This will be 1 minus sine square theta is cos square theta, and to the power minus m is cos minus 2m theta, and this 2 sine theta cos theta d theta is equal to dx. Just simplify it and we get 2 0 to pi by 2 10 to the power 2m minus 1 theta. This I think cancellation you can do and get. Put 10 theta is equal to z, and sec square theta d theta after differentiation is equal to dz. D theta is dz upon 1z square. So we got beta m 1 minus m, which was the left hand side, is equal to twice of 0 to infinity. Limits will change because when theta is 0, z will be 0. When theta is equal to pi by 2 means 10 pi by 2, then z will be 10 pi by 2 means infinity. So z to the power 2m minus 1 dz upon 1 plus z square. We put z square is equal to t, so 2z dz is equal to dt. So beta m 1 minus m is this much, 0 to infinity t to the power m minus 1 1 plus t dt, where m is lying between 0 to 1. Now we have reached to that point which we solved in the question 5C of 1992, and we showed that this is equal to pi upon sine m pi. So this, the rest we have already done this portion, so you can and get see this and go to that question and just thank you.